In today's lesson, we are looking at circles and semicircles. The first equation for a circle that we look at is when it's centered at 0, 0, so the origin. This equation you would have actually seen in years 9 or 10, and it's just x squared plus y squared equals r squared. So obviously r is your radius of your circle. So that just tells you, when you do the square root of whatever that number is, it'll just tell you how big your radius is going out from the center. The second circle that we have to deal with is where we have a center anywhere apart from the origin. And that goes by the equation of x minus a, or squared, plus y minus b, or squared, equals r squared. So we still have r squared to be able to find out what the radius is fairly simply. The other thing we've got to look at is the equation of a semicircle. Now we only look at semicircles where the center is at the origin. We don't worry about semicircles anywhere else. For that, it is plus or minus the square root of r squared minus x squared. If it is a plus version, it means it's above the x-axis. If it's a negative version, then it's below the x-axis. As I've already said, r represents the radius of the circle. So in that equation, x squared plus y squared equals 25. We obviously have a radius of 5 because the square root of 25 is 5. Okay, so for this first example, we need to sketch the graph of the circle given by x minus 1 all squared plus y plus 2 all squared equals 4, and say it's domain and range. Now, the first thing you would have noticed from taking down your notes is that we have the general form that x minus a all squared plus y minus b all squared equals r squared. So we can easily find our center and our radius from this equation. So if we go through, that term is supposed to be minus a. So minus a equals minus 1. So a equals 1. Then we look at that term. That's supposed to be minus b. So minus b equals 2. So b equals minus 2. So we have the center 1 and minus 2. Alright, for the radius, we know that that is supposed to be r squared. So r squared equals 4. So r equals 2. Alright. To actually graph this is fairly simple. So we go through. I'm not going to do a very big graph. Alright, firstly, having a look, our center is at 1 and minus 2, so we go across the 1, down to minus 2, and we draw our center. And we can just label that there, so that'll be 1, that'll be minus 2. So just label them on the actual axes. Then you just measure out your radius. So you go up and you go, alright, well, that's going to be one edge of your circle where that hits the x-axis there. Going across, if we go straight to the right, it's going to go 2 spaces over, so it'll be in line with 3. So we now have a point there. Going down will actually be in line with minus 4, so I might have to extend this graph down a little bit. So I can actually show minus 4. And then over here, it'll be in line with minus 1. And so then you try and draw a circle the best you can. I can't draw a circle, so this will be interesting. Still a pretty horrible looking circle, but it's got all the information that you need for the sketch. Looking at the domain and range. For the domain, furthest it can go to on the x-axis is minus 1, and we can actually touch that, so we use our squared off brackets. So it's minus 1. And then the furthest we can go on the x-axis to the right is 3. Same thing with the range. We go, the furthest I can go down is minus 4, so squared off brackets again because I can actually touch that point. And then furthest I can go up is 0. And we're done. Alright, the second one. We're going to look at finding the equation of a circle with the radius 3 and center minus 2, 1 in expanded form. So the first part is just doing what we basically did in the first part of the last question, is looking at the general form. So we know that the general form is x minus a all squared plus y minus b all squared equals r squared. What we need to do is we need to substitute our values in, so that will be a, that will be b, and that is your r. So we go through x minus 2 all squared plus y minus 1 all squared equals 3 squared. Alright, I'm just going to show the expansion of them, so that would be x plus, because 2 minuses make a plus, so x plus 2 plus 1 minus 1. Alright, now we actually need to go through and expand them fully, so it would be x squared plus 4x plus 4 plus y squared minus 2y plus 1 equals 9. And for expanded form, we basically need to bring everything over so it equals 0 at the end. So we need to bring this over, but then, so that'll become minus 9. But then we also need to bring them 4 over here too. So we go through and we'll say, we'll rewrite everything else. So we'll go x squared plus 4x plus y squared minus 2y. And then when we get to the number part, we're going to do 4 plus 1, which is 5. And then we're going to minus off the 9. So 5 minus 9 is minus 4 equals 0. And that's it, done in expanded form. Alright, the very last example. We're going through and we're finding the center and radius of a circle that is already written in expanded form. Now when it's already written in expanded form, it kind of makes it hard for us to factorize it back into general form. But it is still possible. What we have to do is we have to use the completing the square method. So to start off with completing the square method, we have to move the number to the other side. So we go through and we say x squared plus 2x plus y squared minus 6y equals, and when I've moved the minus 6 over to the other side, it will equal 6. Alright, the next part from that is actually I'm going to leave a bit of space, and for completing the square, remember, we are trying to find a number that we add to the equation to make it a perfect square. But in this case, we're going to have two perfect squares, because we're going to have a perfect square for the x squared and the 2x. We're also going to have a perfect square for the y squared and the minus 6y. So I'm going to leave a space there next to the 2x, then write the plus y squared minus 6y, again leave a space, and then equals 6. Alright, what we're going to do, the reason why I left the space here is because we're going to go through and say, alright, the middle term for the x one is 2. So remember, the fine for completing the square is just 2 divided by 2, and then we square that whole thing. So 2 over 2 squared will be 1. So we're going to add 1 there, but we also have to add 1 at the end as well. Remember, you always have to add 1 at the end. Alright, same thing with the y, so it will just be minus 6 over 2 all squared, which equals 9. So we plus 9 there, and we also plus 9 at the end. Alright, when we're finished doing that, we go through and we say, alright, this one, so this quadratic, that will factorize as a perfect square to x plus 1 all squared. This one here, because we have a minus in the middle, we know that the middle term is going to be a negative, and it's 3, so it'll just be x minus 3 all squared. And then we go through 1 plus 9 is 10, 10 plus 6 is 16. Now we have it in our general form, so it's nice and easy to actually find your center and radius. So for the center and radius, we'd go through and say, alright, so again, that has to equal minus a, so minus a equals 1, so a equals negative 1. And then that is the same as minus b, so minus b equals minus 3. So b equals 3. And then r squared equals 16. So r equals 4. So you would want to write this actual center as a coordinate. So center is minus 1, 3. So we've got the radius and we have the center. Alright, these second two examples are going through semicircles. Now, I separated these because they're separate to circles, but they're actually fairly simple. We have the general form of y equals square root of r squared minus x squared. Alright, that is the general form. Straight away looking at that, we know that the 9 links up with the r squared. So we know that r squared equals 9. So r equals 3. Alright, to actually graph this, we know that there's also a positive one. So if you're looking at your notes, then you know that a positive version is above the x-axis. So it means it's going to be a semicircle above the x-axis. So I'll pretty much just draw up my Cartesian plane. And then I just go to 3 there. 3 there. And then obviously minus 3 over here. And I'm just doing a semicircle the best I can around like that. And there's your graph. So you've already sketched it. You've just shown that the radius is 3 and it's centered at the origin. We only look at semicircles that are centered at the origin. Alright, for the domain and range, sit there and say, alright, the domain is looking at the x values. So the first left we can go on the x-axis is minus 3. And first right we can go is 3. Remember, squared off brackets because we are looking that we can actually touch those points. For the range, 0 is the first down we can go because we don't go below the x-axis. And then going up, we go all the way up to 3. Alright, for the second one, we're looking, because it's a negative out the front, we know that our graph is now going to be below the x-axis. So we know that it's basically just going to look the opposite to that, but then we also have to figure out the radius. So that's going to be our r squared. So r squared equals 4. So r equals 2. Alright. So we can just quickly sketch this. Still not good, but good enough. Alright. We have our sketch. Again, domain and range. So domain. That will run from minus 2 to 2. Range is from minus 2 up to 0.